Hello students, welcome to class 12 physics class. In last class we discussed about the interference interference fringes, condition for constructive interference, destructive interference, coherent sources, these things. So today's class we started with some numericals with whatever we get the formula for constructive and the destructive interference, and the intensity formula also we derive. Using that formulas we solve two numericals. After that we go to the next theory of interference, that means we find out the width of the fringe, dark fringe and the bright fringe. So first numerical, here it is given that in this Young's double slit experiment, and the intensity of light at a point on the screen where the path reference is lambda is k unit, its value is k unit. Find the intensity at a point where the path difference is lambda by 4, lambda by 3 and lambda by 2. So I will discuss lambda by 4 only one, and the other rest 2 under lambda by 3 and lambda by 4 in a similar way we can find out. Here both all are uh, all are solved, but I will discuss only one. So we know this formula, intensity formula, I equals to I1 plus I2 plus 2 root over I1 I2 into cos phi. Now because from both the sources the fringes or the waves are started, so the intensity of either sources, that will be the I0. So we can say that I1 equals to I2 equals to I0. So if we put that values over there, we get one equation, I equals to 4 I0 cos square phi by 2. Now one line is written over there in that question. If the path difference is lambda, if path difference is lambda is k unit, so path difference we denoted by p, so p equals to lambda. So if p equals to lambda, so phi equals to what? Phi equals to 2 pi, because we know that phi is a phase difference. Phase difference equals to 2 pi by lambda into path difference. So using that formula we can easily find out the phase difference if the path difference is given. So from that we can find out p equals to lambda, so phi equals to 2 pi. So if we put this value in that equation, I equals to 4 I0 cos square phi by 2, that means in place of phi we put 2 pi. So we get this equation I 4 I0 cos square into 4 pi, that is equals to 4 into I0, that is equals to k. Clear? So because I0 equals to I0 value is k denoted by k unit, so in place of I0 or I0 we can write k. So I equals to we get k, that is a from first. From first the hints we find out these things. Now we find out if the path difference is lambda by 2, then what will be the intensity. If the path difference is lambda by 2, lambda by 4, then phase difference equals to, using the formula lambda by 2 pi into phi, so phi equals to 2 pi by lambda into path difference lambda by 4, so we get pi by 2. So if we put in place of phi pi by 2, we get pi by 4. So the cos square pi by 4 value is half, so we get 2 I0. I0 value is k, because 4 I0 equals to k, so 2 I0 in place of 2 I0 we can write k by 2, so I equals to k by 2. So whatever the first intensity, that will be the half for this path difference. Similar way we find out the second and third number. First we find out the phase difference phi using that formula, then we put the value of phi in that equation and we get the value of intensity in terms of k. So for second case, if the path difference is lambda by 3, the intensity will be k by 4, and if the path difference is lambda by 2, then the intensity we get 0. Clear? Okay, now next another one. Two coherent monochromatic light beams of intensities I and 4I. So two intensities is given. From one source the intensity of light is I, another one source intensity of light is 4I. So I1 equals to I2 equals to 4I are superposed. What will be the maximum and minimum possible intensity? Okay, we know this formula. So in place of I1 and I2 we put the values I and 4I, so we get one equation in terms of I equals to 5i plus 4i cos phi. Now intensity is maximum when phi equals to 0. So phi equals to 0. So if we put this, because cos phi, cos 0 value is 1, that is the maximum value, that's why phi equals to 0. So if we put over there, we get 5i plus 4i, that is 9i, that is I maximum. And I minimum when phi equals to pi. Pi cos pi value is minus 1, that is a minimum value. So we get I minimum equals to I, 5i minus 4i, that is equals to I. This type of numericals will come in exams for numerical based. Another different kinds of questions will come, we discuss this later after completing this chapter. Okay. Now, Young's double slit experiment. We only talks about the Young's double slit experiment, but what is that experiment? This is the experiment. One is source single slit, another one is a double slit. From double slit, the sources are the different kinds of intensity or different waves are started. They will superimpose each other. If we placed one screen on the screen, we get the fringe pattern. Sometimes some places it will be bright, some places it will be dark. So like consecutive bright and dark, like this pattern we get, that is called interference pattern. Is it clear to everyone? I think this is a Young's double slit, because two slits we use for two waves, and from one source the light wave will come. From two sources, that will be divided in two waves, S1 and S2. S1 and S2 are the two narrow slits at equal distance from S. And S is a monochromatic light source. We can say that these things. So for derivation of fringe width, we use this diagram. The below that diagram with a dotted line. So in this diagram, you see that the center point at O, that is a center where we get the maximum brightness, intensity is maximum, that's 0. Direct light is fall on the will fall on the screen, that's why we get the bright uh, fringe. Now from slit S1 and S2 at a distance D is the distance from the screen to the slit. We consider at a point P, we don't know at a point P which interference fringe will either it will be constructive or it will be destructive. So we find out both condition. If it will be constructive, then what happened? If it will be destructive, then what will be the fringe width or what happened? These things we details in next slide. Here I will draw this diagram again. So in this figure you see that the waves is from S1 and S2. Okay, so being derived from the same parent source S, the slits S1 and S2 acts as a coherent sources. You remember in this mind, in your mind, and this S1 and S2 are separated by a small distance D, and the distance between the screen and the slits, that will be capital D. So we consider a point P on the screen at a distance x, or at a distance y, at a distance y from the center O, and the nature of the interference at the point P depends on the path reference, that is P equals to S2P minus S1P. So we find out the value of S2P minus S1P. How we can find out? It is a geometry. From the triangle S2BP and the triangle S1AP, we can write S2P square minus S1P square, that is equals to S2B plus PB square minus S1A square plus PA square. Now S2B means capital D square, plus PB means y minus d by 2. Y minus d by 2. PB means. So y plus d by 2. Sorry. So y plus d by 2 whole square, minus like this way S1A, that is equals to d, and PA means y minus d by 2 whole square. So after solving we get S2P minus, because this is A square minus B square formula, A plus B into A minus B, that is equals to 2YD. So S2P minus S1P equals to, we get 2YD by S2P plus S1P. Clear? Now because this P point lies very close to the center point, that is very close to the O, Therefore, we can consider this distance S2P equals to S1P will be similar, that is equals to D. S1P equals to also D, S2P equals to also D. So, that means in place of S2P plus S1P, so D plus D, that is 2D. So, S2P minus S1P, that is equals to 2YD by 2D. S2P minus S1P, it will be the path difference. S2P plus S1P, it is not a path difference. So, P equals to, we get YD, Y small d by capital D. This is a path difference between the two waves. Now, the position of bright fringes. If at point P, bright fringes are constructed, then what will be the positions of bright fringes? For constructive interference, P equals to YD by D. We know that in the last video we discussed that is equals to n lambda. Okay, we discussed these things in the last slide, that we also get the for constructive interference, the path difference will be the integral multiple of lambda, integral multiple of the lambda, wavelength lambda. So, we use that concept here. So, P equals to one equation we get, that is YD small d by capital D, that is equals to n into lambda. So, Y equals to, we can write n lambda d by d, where n value started from 0, 1, 2, 3 onwards. Now, if we find out if n equals to 0, that means the center point. If n equals to 0, so y0 equals to 0. That is a center point, central bright fringe. Now, for n equals to 1, we get y1 equals to lambda d by d. This is the first bright fringe. Now, n equals to 2, y2 equals to, we get 2 lambda d by d. This is a second bright fringe. Like this way, if you want to find out the position of nth bright fringe, so yn equals to n lambda d by d, that is for nth bright fringe. This is the position of bright fringe from the center. Clear? Now, if we find out, so at point P, we consider the bright fringes are constructed, and whatever the position that is y is the distance from the center, y is the distance from OP is the y. So, thus y is the distance of the position of the bright fringes from the center. So, now if we find out the width of the dark fringe, so first is the bright fringes is constructed, then dark, then bright. So, if we want to find out the width of the dark fringe, that means that is a separation between two consecutive bright fringe. That means if we want to find out the dark fringe in between n1 and n2, so if we subtract this two value, we get the width of the dark fringe. So, the separation between two consecutive bright fringe gives us the width of the dark fringe. So, that is equals to y2 minus y1. So, if we put the values, we consider here only n2 and n1. But if you want to find out the n and n minus 1, then also you can write in place of 1 and 2, you can write yn minus 1. So, we get lambda d by d, and the width of the dark fringe it's denoted by beta. So, beta equals to lambda d by d. So, normally in general formula is yn, within bracket I will write these things, yn. If you compare with this y2 and y1, so n value is 2, n minus 1, that is 2 minus 1, that is 1. That's why y2 minus y1. So, in general formula is yn minus 1, that is equals to beta fringe width. Now, if you want to find out the position of dark fringe, so we know that for dark fringe P equals to, the path difference will be 2n plus 1 into lambda by 2. There is a two conditions. If you want to use 2n minus 1 lambda by 2, then n value started from 1, not from 0. Now, if you want to write 2n plus 1 lambda by 2, then n value started from 0, 1, 2 onwards. So, that is depends upon you, but keep it in your mind, if you use minus, then n value you write started from 1, 2, 3, not from 0. So, I will use here the plus 1. So, that is why I write n equal value started from 0, 1, 2, 3. So P equals to yd, that is yd by d, that is equals to 2n plus 1 lambda by 2. So from here we get one equation of y, that is 2n plus 1 by lambda by 2n plus 1 into lambda by 2 into d by d, where n value started from 0, 1, 2 onwards. Now if we put n equals to 0, n equals to 0, y0, you see that in first position of bright fringe we get y0 equals to 0, but here y0 equals to lambda d by 2d. Okay, this is a central dark fringe, you can say that. Actually it is not possible, at center the total maximum intensity brightness is maximum, so we did not get the dark fringe at the center. So now n equals to 1, if n equals to 1 you get 3 lambda d by 2d. This is a first dark fringe. Y2 equals to, if you put the y n equals to 2, then 5 lambda d by 2d. This is a second dark fringe. Now like this way, if you want to find out nth, yn equals to 2n plus 1 lambda d by 2d. This is for nth dark fringe. Now so if you want to in this in here you find out the position of dark fringe. So from here you can find out the width of the bright fringe, that is the separation between two consecutive dark fringe gives us the width of the bright fringe. So y2 minus y1 gives us the bright fringe in between y2 and y1, that is equals to, we get lambda d by d, so beta equals to lambda d by d. So that in general formula will be same for the constructive and the for destructive, for bright fringe and for dark fringe. The in general formula will be same. The width of the fringe will be same, that is lambda d by d, and yn minus 1, that is equals to beta. As beta is independent of n, the order of n is the order of fringe, first order, second order, third order, how many fringes you get. Therefore we can say that all fringes are equal width, because for both cases we get the same value. In the case of light, lambda is extremely very small, d should be capital D, it should be much larger than the small d, so that the fringe width beta may be appreciable and hence observable. It when we do this practical, we keep it in your mind that the capital D should be, that means the distance between screen and the slit must be larger than the slit distance. Now Young's double slit experiment can be used to determine the wavelength of a monochromatic light. The interference pattern is obtained in the focal plane of a micrometer eyepiece, that is one prism table also be there, a spectrometer, where we perform this all practicals like fringes, we use the slates also be there, grating also we one type of device, grating. So that device is called spectrometer. With its help, fringe width beta can be measured. By measuring the distance small d between two coherent sources and their distance capital D from the eyepiece, that means the screen from where we see the first order, second order fringes. Okay, in a experiment there will be no screen, through the eyepiece we see the first order, second order, third order. Okay, the value of wavelength can be calculated by lambda equals to beta small d by capital D from this experiment. So we can say that it is clear that for both bright and dark fringes are equal width, that is lambda equals to lambda capital D by D. Clear? Okay. Now here this things is whatever I just now whatever I said, all these things are written over there. The appreciable fringe width, d should be larger, d should be small. Beta is directly proportional to lambda. Fringes produced by light of shorter wavelength will be narrower as compared to those produced by light of longer wavelength. These things it is written over here. Angular width of a fringe, as all bright and dark fringes are the same width, the angular width of the fringe is given by it is measured by theta. It is written over there, theta. Theta equals to beta by capital D. So beta's value if you put over there, then capital D cancel, we get lambda by small d. All dark fringes are the same. If the all dark and bright fringes are same width, then the angular width is denoted by theta. Now, if Young's double slit experiment apparatus, this total apparatus, if it is immersed in a liquid, then what happen? In a liquid, suppose water. So the wavelength of the light decreases because refractive index mu, the wavelength of light, it depends upon the in a liquid, whatever the liquid, suppose it has some refractive index, we consider the refractive index is mu, or you consider n. So the wavelength of light decreases, and so the fringe width reduces to its initial value, reduces to initial value. That means if it will come, question is there, what happen if the total apparatus or the Young's double slit experiment arrangement totally immersed in a liquid, then the light wavelength is decreases because lambda is decreases and beta is directly proportional to lambda. So the width of the dark fringe or the bright fringe is also reduced by its from initial value. Now, condition for sustained interference. Sustained interference, uh, in order to observe the interference pattern, it is necessary that positions of maximum and minimum do not keep on changing with time. Otherwise, the maxima and minima of intensity will mix up together and produce an illumination. So, the interference pattern in which the position of maxima and the minima of intensity on the observation screen do not change with time is called sustained or permanent interference pattern. There will be some conditions also be there. Two sources should be continuously emit waves of same frequency or wavelength. The two sources of light should be coherent. For a better coherence between maxima and the minima of intensity, the amplitude of the interfering wave should be equal. The two waves must have same amplitude for better contrast between bright and the dark fringe. The sources should be monochromatic, otherwise the fringes of different color will overlap, and many conditions are there. I will write here five. Many conditions are there. Two sources, the two slits should be narrow, otherwise interference will occur between the waves of different part of the same source and construct will be poor. So the fringes will be hazy, comes in hazy. There will be some numericals related to the that beta fringe width. So you try to in your home. It is mentioned in details. It's solved it here. This is the intensity distribution curve of interference. That is you see that here, the beta, the width of the dark fringe, and the so the in the left hand side where it is arrow sign over the dark fringe. That means if we find out the width of the dark fringe, so we have to subtract the two consecutive bright fringes. Same for bright fringes also. Whatever the value we get, first order, second order, third order, you see that in this pattern it is all these things are mentioned. Okay, so I hope only the diffraction is left, diffraction portion. After that this chapter is completed. If you have any problem, please write in a comment box. Thank you very much. Have a nice day.